I thought it would be cool and fun to try out different programming languages to implement a Base62 encoder decoder. And I started off writing it in Java, and then there was a project where I needed to learn Clojure, so I decided to port it to Scala and then compare the Clojure functional programming to the Scala functional programming because I was more familiar with Scala, and it was just kind of a way for me to get up to speed. Now that I've done it, I decided, well, why don't I compare it to other things? So I converted it back to functional Java. I wrote it in Python, JavaScript, TypeScript, Kotlin, and Rust, and Golang. And then I'm just kind of looking at those and looking at the type of functional programming they support. Last time I looked at Python a little more detail. It's actually really good, even though the founder, if you will, Guido van Rossum, isn't a particular fan of that style of map and filter and whatnot. He prefers list comprehensions with for and if. But even though that's the case, you can still do that type of programming, and actually Python and Scala look very similar when you do that sort of functional programming. So it's a really good language to do functional programming. Now let's take a look at JavaScript and TypeScript, and I think what you'll find is that both of these are really solid because they had their foundations in functional support. Scala is still my favorite, but these are actually pretty good. So here we are. We're going to talk a little bit about the JavaScript, TypeScript, Base62 example. So this is the JavaScript version. I got the short link here, a lot of the same background material that we showed before. So if you want to know about Wikipedia shortening or want some examples of shortening services, they're all there. And then there's links to the first video, second video, and so on, and a little description of how shortening applications work, and more about the tutorial. And it's something we've been working on a while. Of course, there's a little bit about me as well. So the first video is the Base62. Now we're on the, what is this, the fourth, the fifth? It's the fourth video in this series. And in this time, what we're going to do is we're going to implement it in, just showing some different language that we implemented in, right, in the past. And now we're going to implement it in JavaScript. So we've done it in Python, we've done it in Clojure, we've done it in all these different languages, and now we're going to implement it in JavaScript in this video. So here's the Scala version on the left. I like the Scala version because it's short, it's terse, and it's pretty easy to understand. And that's the equivalent JavaScript on the right. There's no real main method, so you just kind of start there, I mean, you could write a main method, we could have called it, but you can see that the code is equivalent. One is JavaScript, the other is Scala. And we call it a hash code function, which is going to be a little bit different for each. And then here's our convert to encode string. If you followed the earlier videos, it's something that we covered before. So we've got convert to encode string, accumulate digits. On the other side, we have convert to encode string, accumulate digits done in JavaScript. We'll show another version in TypeScript. And they're very similar. In fact, it felt kind of natural to kind of move these back and forth. It was a lot harder, I would say, to convert from Java to Scala than it was to convert from Scala to JavaScript once we wrote the functional version of Scala, so to speak. I'm sorry, the functional version of this application. And then we have the find first bucket, just kind of showing it's pretty similar. I don't know if these are the best absolute versions of these methods that you could ever do, but it's equivalent. You notice here on the left we've got built-in support for optionals or option, and on the right we're using the Elvis operator to do sort of the equivalent. So we get the get or else 0, and on the right side there we got the return index $index :0, which is about as close as you can get in Scala, in JavaScript rather. Boy, lots of editing for the editor there. All right, that's the Elvis operator there. And then here we have the power digits base, and you could have done this different ways. Definitely, there's math libraries as well, but here we made them both as a recursive function. There's the Scala version, the JavaScript version, pretty close. I mean, other than Scala is type, but once we get to TypeScript, that difference is going to be gone. It's going to look even closer. But you can see even now, it's pretty equivalent. And again, once you get to TypeScript, it gets even closer, the syntax. You can kind of see these languages converge on a syntax. Scala and Kotlin look a lot alike. Kotlin and Swift look a lot alike. And you can see here Scala and JavaScript look a lot alike, and it's going to look even more like when we're doing TypeScript. And then there's our convert to long. If you remember, doing this in Java was a little bit tricky because of the support for reduce / fold left in Java is a little bit sus, if you recall. It's just a little harder to understand the way that the type system works. It's a little easier in the Scala world. And you have support for things like tuples. JavaScript doesn't have tuples, but it has lists, which kind of can function like tuples. So it makes it fairly easy. And you can see the kind of equivalent left and right. It's pretty darn close. Slight syntactic changes, but it's pretty easy to translate. If you go back and forth, of course, you're going to forget to put the return statement here and there, but that's usually pretty easy to figure out. Really do like that idea in Scala of statements all having they're basically all expressions. Everything's a value. That's as you remember from the closure example, we had that as well. So here's the full code listing if you want to go through it. It's lovely. Now we get to the TypeScript. It's the same. It looks the same. It's so much similar. I mean, it looks very much like the JavaScript, but it's even more like Scala because it is typed. So other than string being lowercase and JavaScript and TypeScript having this loose version of what a number is, it works really well, and the code looks very close. Make string versus join, they do the same thing. This is just very easy to follow. I think if you were on a project, you had to go back and forth between TypeScript and Scala, it's going to be a lot easier than most. Of course, with the tuples, you've got the underscore notation, and with the list, you've got the normal arrays, rather, because those are really arrays, not lists. Get my languages mixed up. That would be Python, where they're lists. And then we have you can see, it's real easy to map them one from the other. You can kind of see how it all fits together. It's very easy to kind of go back and forth and see where these things fit. Now it gets a little wonky because I decided to use the list syntax in Scala because there are some differences versus the append in TypeScript. And then we got the compute value. Very, very similar. I mean, if you kind of squint your eyes, they look identical. And then here's the full code listing of TypeScript, which I think really matches the Scala, which I've kind of made Scala the one that I, once I converted from Java to Scala, I kind of made the Scala as the one that I convert from because it's real easy to follow. And it's the full listing. Okay, so let's take a look at the code. So what we're going to do now is we're going to, we're going to do a git clone. We're going to pull down the TypeScript and JavaScript from GitHub. Now let's take a look around here. Let's see. First, we can go into the directory. That's where we just pulled it down. Do a tree command. So we got a JavaScript folder, a TypeScript folder, package.json. We have a main.js and a main.ts, which is a TypeScript. Let's take a look at those files. So you can see, function compute, just like we were talking about. Find index of function. You can see it's there. And now let's look at the TypeScript one and see if it has the same. And lo and behold, what does it have? The same, except now with types. That's right, types. Yay, that's good. Now let's go ahead and load it up in the IDE and take a look at it again. Okay, so we clone that code off of GitHub. Now let's open it up in our IDE. So I'm going to go File, New, Project from Existing Sources. I am going to, what am I going to do here? I'm going to grab Base62, this guy. I'm going to grab the JavaScript one first. Open that. Create project from existing sources. Create project from existing sources. Hit next. I'll call that JavaScript. That's fine. Next. Create. We'll do a new window. And now we should have JavaScript. Make that a little larger. And here's our JavaScript code. So convert to encoded string. find start bucket, yada, yada, yada. So now we'll go down here at the very end. We just have code that we can run. So it'll basically execute those methods. We'll call convert to encoded string, and we'll show both, this is the numeric version. That's basically the string version, and that should equal that. So that'll print out this, and this will print out that. And then we have this long URL. We'll get the hash code. Notice the hash code operation up here. Later on, we'll compare that to the TypeScript one. We get the short handle. We print out the short handle, and we convert the short handle to long, just to basically show that we got the URID, then the short handle, and then when we do convert to long, we'll see the URL ID again. So the URL ID is basically the hash code. All right, so that's what we do. Now we're going to run this. Hit run. Okay, so I had to bust out my glasses and then install Node. And I used Brew. I used Brew to install Node, so I do a Brew install Node. Got my JavaScript environment set up, and then of course I'm going to get an ad from JetBrains. I'm going to dismiss that, and let's just talk a little bit about how we set things up. Well, first I need to edit my configuration of this project, and now, as you see, user local bin node, that's where Brew installed my Node instance. You might use Choco if you're on Windows, or apt-get if you're on Linux, but you get the idea. Now I can run it. I can run it right from my IDE. Now the key thing to note here is in the program, I give it a number with the convert to encode string, and it gives me a string. And then with the convert to long, I give it a string, and it gives me a number. And that string, that first string, that DTV D30, that's the Base62 version of 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0. So that's how that works. Now, typically you'd use this with a URL. So here on line 104, I've got this long URL. I take its hash code, I get the absolute value of it, and that's the URL ID. And then I use the convert to encode string to create the URL version. I first convert it to a number from the URL, and then I convert it to a Base62 string. I hope you enjoyed that video. I've got some more to come. We did a few more programming languages. We tried Rust and Go, and and I think we're pretty much done with the Base62 stuff, and we're going to start focusing on some other things. I've got some things to do with kind of computer science, building heaps, different algorithms, different data structures, and we might do some machine learning AI as well. So tune in. See you next time. Thanks for tuning in. Appreciate it. Subscribe, like, share, I don't know, whatever they say. Sounds good.